Hi, here is your video for section 2.4. We are now getting to the second half of chapter 2. The first half, it deals with equations and our answers being considered solution sets. So all of our answers were in set notation. The second half of chapter 2 deals with inequalities, so linear inequalities in one variable. And we've been used to representing our inequalities in normal x greater than 5 or x less than 5. But now we're going to learn something that's called interval notation, which might not have been presented to you last year in Algebra 2. So let's go ahead and talk about that. And again, pause this video at any point in time if you feel like you need to just stop and get everything jotted down before you move forward. Okay, so here's our key concept for the beginning of this section. What is interval notation and what does it look like? So there's two different notations that we should be aware of: set notation and then interval notation. And then I'm going to present a graph of these two things just so you can visually see what that looks like. Okay, so here are our options. What we first have been used to seeing is something of the form, and I'm going to just use numbers instead of variables so it doesn't get so confusing. If you had something like x is less than 5, all right, we know what that looks like on a number line, don't we? That's right here. I'm going to throw 5 in the middle. And remember, we would make an open dot. Don't put this in your notes quite yet because this isn't what I want you to be doing. And then everything would be shaded to the left. Remember doing that? Okay, well now again, we're advancing our algebra. We're making it look a little bit nicer. So set notation means we need to have those curly braces. Oh, those look pretty good. I'm quite impressed with myself. But it's not just the set of x less than 5. It's x, and then we put this vertical bar here. And that vertical bar stands for the words such that. So if I were to read this notation out in words, I would say all values of x such that x is less than 5. So such that, I realize I didn't put that there. Okay, now we don't normally write our answers in set notation. Our textbook wants all answers in interval notation, which is what I will also want. So anytime you are solving an inequality, your answer should always be written in interval notation. So what does interval notation look like? Okay, so let's go back to that graph. So now I do want you to put this graph on. So let's make a graph and put 5 in the middle. In the past, we would do open dots when I don't have an equals to sign with my inequality. And we would put a closed dot when we had the equals to in our inequality. But now instead of open dot or closed dot, so you might want to make a little star somewhere. Instead of an open dot, we're going to use parentheses. And instead of a closed dot, we're going to do square brackets. Okay, and you make your parenthesis or your bracket face the way that your shading would go. So for example, for this one, since I want all values of x that are less than 5, because it's not equals to, it's going to be an open parenthesis facing the left because I want it to go less than, and my shading would go then to the left. So this is what your graph would look like. Okay, so instead of an open dot, I have a parenthesis, and it's going to the left. So what does that look like in interval notation? Well, it's easy to see from the graph and then you just kind of take it from the interval notation. So interval notation goes from left bound to right bound. So on my graph, what is the furthest left point that's on it? Well, it keeps going on and 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 on in the negative direction. And it's going to keep going all the way to negative infinity. So I'm going to do a parenthesis, negative infinity, comma, and then my right bound is 5. I'm going to put a parenthesis there because it doesn't include 5. It's all values less than 5. So in my interval notation, my left bound means that my furthest left is negative infinity, which means it's going on and on forever. And my upper bound is 5, not including it because it has the parentheses. If we were to change my set notation to the value of x such that x is less than or equal to 5, what would change on our graph? Well, instead of a parenthesis at 5, it would be a closed dot, but in advanced algebra, we don't use dots. Those are pretty elementary. We would use a square bracket, and then we would do some heavy shading to the left. So in interval notation, what would change? Well, my 5 would be closed with a square bracket, which tells me that it is equal to 5. I'm still going to have my negative infinity because my graph just keeps on going on and on and on and on to the left. That was really bad infinity. I can do better than that. But because we can never equal negative infinity, because really what is negative infinity? It's not a number. You will always have a parenthesis connected to your negative infinity. Okay, so I've got set notation, interval notation. It's very important that you learn how to do your interval notation because that's how all your answers are going to be. When you make your graphs, instead of open or closed dots, you should be doing parentheses or brackets. Okay, pause there. I'm going to erase this. So if you need to take a moment to get the rest of this copied down, go ahead and pause the video or rewind back. So now let's go to the other side. Let's do the set of all x values where x is greater than 5. Well, what would that look like on a graph? So we have our 5. Again, we don't have the equals to, so I'm going to do a parenthesis, but since I'm going larger, I'm going to open that parenthesis to the right and then shade heavily to the right. In interval notation, now my left bounds, we work from left to right. My furthest left number is 5. So that's going to go on the left side of my interval notation. Oops, not negative 5, 5. It's a parenthesis because it doesn't include it. And we're going all the way to the right, which takes us all the way to positive infinity. So I'm just going to put infinity there. And again, always attach a parenthesis to infinities because you can't actually equal infinity. It's not a real number. It's just a representation of going on forever, can't stop. So now let's put an equals to down. So the value of x such that x is greater than or equal to 5. So on our graph, we would be at 5, square bracket, shading to the right. Interval notation, square bracket at 5 to infinity, close it. Okay. All right, so let's do some quick, see if we got this topic down. If I had to do x is less than or equal to 4, in interval notation, so what does that graph look like? Well, here at 4, it would be a square bracket, shading to the left. So in interval notation, that would be negative infinity to 4 square bracket. So we see that? If I did x is greater than 4, well, graphing wise, putting 4 there would be a parenthesis and not a square bracket because I don't have the equals to, shading to the right. So at interval notation would be 4 to infinity. If I had to do x is less than or equal, or let's do x is less than 10, an interval notation, negative infinity to comma 10 parenthesis. If it was x is less than or equal to negative 3, then it would be negative infinity to negative 3 bracket. You see this? Keep doing a few until it sinks into your brains. If we were doing x is greater than or equal to 20, then it would be bracket 20 to positive infinity. Or x is greater than or equal to 2, bracket 2 to positive infinity. Notice all the infinities have parentheses around them because we can never ever equal them. Okay, do we think we have the hang of that? Okay, so now let's do our special cases. So still working on the same table. What if we had a lower or an upper bound that was not infinity? So what if we were doing something such as the set of all x values where x is between two numbers? I'm going to go 1 and 2. Those are two good numbers. So what would that look like in a graph? Well, we got 1, we've got 2. X needs to be in between those two. So what numbers are between 1 and 2? Well, all of these right here where I'm shading. Because there's no equals to, I'm going to put a parenthesis and then a parenthesis. So now translate that into interval notation. My furthest left bound is right here. My further right bound is right here. So I get parenthesis 1, comma 2 with a parenthesis. Now let's change that up a little bit. Let's make it the set of all x's such that 1 is less than or equal to x less than or equal to 2. So let's throw equals to into that. So in our graph, again, x is still in between those two numbers, but now I'm going to have square brackets I can't say the word. Accompanying, nope, now I can't even say it. Including all those values in there, bookmarking all those values in there. I don't even know what word I was trying to say. So in interval notation, we have square bracket 1, 2, 2 with a square bracket attached to it. What happens if I have a mix? So if I had the values of x such that 1 is less than x is less than or equal to 2. Well, then I would have a parenthesis at the 1 and a bracket at the 2. So everybody see that? Because there's not an equals to sign at the 1, so I'm not going to equal it to it, so I don't include it, so I put a parenthesis there. I do have an equal sign at the 2, so I would put a bracket there. Or if we flipped it, x such that 1 is less than or equal to 2, less than 2, then it would be bracket 1, comma 2, parenthesis. So you can have situations where you don't have the same notation at the beginning and the end of the interval notation. That makes sense. Okay. So what would x such that or in between 3 is less than x less than or equal to 5? Converting that to interval notation would be 3, comma 5 with a square bracket at the 5. Everybody see that? Or x such that 2 is less than or equal to x less than or equal to 10. Well, since there's both equals to's, I'm going to have square brackets there. Okay. All right. So those are our compound inequalities, our triple inequalities, which we'll get to some examples of where that comes into play. And then the last two scenarios that we have to get into are our no solutions and our all real numbers. So let's cover our all real numbers first. So let's do the set of all real numbers. There's our set notation that we've done in the past. What does that graph look like? Well, it's just the whole entire number line, right? So that's kind of silly to graph it. So the most left bound on that graph is negative infinity. The most right bound on that graph is positive infinity. So my interval notation for all real numbers is all numbers between negative infinity and positive infinity. That's your interval notation. Okay, so when you are solving an inequality and your answer is all real numbers, you should be writing your answer like this and not like that. Okay, if you're solving equations, then you can write your answer like that and not like that. Okay, so you got to be aware of what the task is at hand. All right, and then let's do a no solution. So remember, here's our answer for no solution. What does a graph for no solution look like? Nothing on the graph. It's just blank. So there is no left bound. There is no right bound. So your interval notation is, again, just plain old no solution because there was no solution. Okay. All right, so now that we've got all of our interval notation taken care of, again, we'll be using it throughout these examples, so you'll get extra practice with it. Let's go ahead and solve and graph some solutions or of some inequalities. So here we have x minus 7 is less than negative 12. This is a very easy one-step inequality to solve for. It's meant to be easy on purpose. Add 7 to both sides. Gets you x is less than negative 5. Okay, so in the past, we would be done and we'd say that's our answer. Let's go ahead and make a quick graph of it. Again, you can be lazy. Just throw negative 5 in the middle. No equal sign. So I'm going to make a parenthesis. Open to the left, shade to the left. Interval notation, negative infinity to negative 5, parenthesis. There's your final answer. You don't make this one fancy because it's in interval notation, not set notation. So don't put these squiggly curly braces around it. All right, let's do another one. Make it a little bit harder. Exit out of there. 14 plus 2m is less than or equal to 3m. Okay, so I'm going to subtract my 2m over, which gets us 14 is less than or equal to m. Me personally, I always like to get in the habit of writing my variable on the left-hand side. So if I were to flip-flop that, notice that my alligator is eating the m, so I want to keep it open to the m. So 14 less than or equal to m is the same as m is greater than or equal to 14, which just makes it easier when we go to graph it. So when I put 14 in the middle, I'm going to have a bracket, a square bracket. So I have the equals to there, shading to the right. So my answer in interval notation is going to be square bracket 14 going all the way to positive infinity. Again, pause this video at any point in time, repeat whatever you need to repeat. I'm going to keep on moving to try to keep it going slower. Okay, so now try this one on your own. Hopefully your answer was bracket negative 4 to infinity. And just from feedback before, I'll actually work through it to see how your mistakes occurred. So subtracting 4x from both sides gets us x plus 3 is greater than or equal to negative 1. Subtracting 3 gets you x is greater than or equal to negative 4, right? So then if you think about that, we weren't asked to graph it, but sometimes it's easier to see the visual. There's the visual of the graph. So my left bound is negative 4. My right bound's going to positive infinity. Okay, very good. Now let's do some division work. Here we have 5m is less than or equal to negative 30. Dividing out your 5 gets you m is less than or equal to negative 6. My graph, negative 6 in the middle, bracket facing to the left, shading to the left. Interval notation, no, did that wrong, negative infinity to negative 6 with the square bracket. Next one, now we have a coefficient in front of our k that is negative, so we got to be careful here. Dividing by a negative 4, you have to remember what happens to your sign when you divide by a negative 4. Remember, you have to flip the sign anytime you divide or multiply by a negative number. So my result is k is greater than or equal to negative 8. That graph would look like this. Square bracket at negative 8, facing the right, shading to the right. Interval notation, negative 8 to positive infinity. That's my final answer. And we'll make it a little bit more elaborate here. Negative 4 times the quantity x plus 4 plus 2 is greater than or equal to 7 minus x. Distributing gets us negative 4x minus 16 plus 2 is greater than or equal to 7 minus x. Combine like terms, negative 4x minus 14 is greater than or equal to 7 minus x. Move your smaller x over. So I'm going to add 4x over to both sides. Gets me negative 14 is greater than or equal to 7 plus 3x. Subtracting 7 from both sides gets us 21. Negative 21 is greater than or equal to 3x. Dividing by 3 gets us negative 7 is greater than or equal to x. Again, just for graphing purposes, it's nicer to flip that. So notice it's open to the negative 7 originally, so make sure it stays open to the negative 7 here. So now when I make my graph, the shading is going to go in direction of my inequality. So bracket at the negative 7, shade to the left. Notation-wise, we're going negative infinity to negative 7 square bracket. Again, pause this at any point in time, replay it, let it soak in, do what you think you need to do. You're going to go ahead and try this one on your own. Oops. Guess I didn't copy and paste that. Is that the right answer? 0 to infinity. Let's go ahead and work through this one. So we have parentheses 6x minus 6 when you distribute, plus 3x greater than or equal to negative x minus 3x minus 6. So now we get 9x minus 6 is greater than or equal to negative 4x minus 6. And then adding your 4x over gets us 13x minus 6 is greater than or equal to negative 6. Adding 6 over gets us 13x is greater than or equal to 0. Dividing by 13 leaves us with 0. So graph-wise, 0 is in the middle, bracket, shade it to the right, bracket 0 to infinity, which is what I had in that last slide. I just didn't copy and paste the original problem over. All right, let's move on. All right, well, now we're going to start getting into our advanced harder problems. So now let's deal with these fractions. Again, pause this video if you need to take a moment to get this copied down. I'm going to start plowing through. I'm looking at all the numbers that are in my denominator. I have a 3 and a 2 and a 2. So my least common denominator between those would be a 6. So I'm trying to think of what number, smallest number that I can get in my brain that's divisible by both 3 and 2. So if I multiply the whole entire thing by 6, that's going to eliminate my fractions. So 6 times negative 2/3. Well, 6 divided by 3 is 2. 2 times the numerator of negative 2 is negative 4. So that becomes a negative 4 times r minus 3. 6 times a half is 3, so minus 3 is less than 6 times a half is 3 times 5 minus r. Distribute. Negative 4r plus 12 minus 3 is less than 15 minus 3r. Combine like terms. Negative 4r plus 8. Nope, 9 is less than 15 minus 3r. Adding 4r would give me a positive variable. Then I won't have to worry about flipping my sign and dividing by negative. So 9 is less than 15 plus r. 9 minus 15 gets us negative 6 is less than r. Okay, so I'm going to rewrite it, which really is r is greater than negative 6. Graphing that, negative 6, parenthesis, shade to the right. Interval notation, parenthesis, negative 6 to positive infinity. Okay, so a bit more challenging because we have fractions. But fractions aren't too terrible because you can get rid of them very easily. All right, so go ahead and try this one on your own. Hopefully you got an answer of bracket negative 13/2 going to infinity. I'll work it through for those who did not get that. All my denominators here are 4, so that's nice. I don't have to think too hard about getting rid of my fractions. multiply everything by 4. So a fourth of 4 is just 1. So that leaves me with just m plus 3. 4 times 2 is 8. So 4 divided by 4 is 1 times the numerator of 3 is 3 times m plus 8. Combining like terms gets us m plus 11 equals 3m plus 24. Subtracting an m gets us 2m plus 24. Subtracting 24 from both sides gets us negative 13 equals 2m. Dividing it gets us, oops, how did my note inequality turn it into an equal sign? That was silly. Less than or equal to, less than or equal to, less than or equal to, less than or equal to. So then we get, there we go. 13 halves is less than or equal to m when you divide by 2, which is really the same as m is greater than or equal to 13 halves. Where'd the negative come from? Did I just type that in incorrectly? Am I missing a negative? Yes, I am. Right here, subtracting my 24. Wouldn't that have gotten me negative 13? Yes, it would have. So bracket negative 13 halves to positive infinity. There you have it. Don't make those mistakes. All right, so now let's get into our special cases. So those all real numbers and those contradictions, the no solutions. So let's see what happens when that happens. So here we have 3 times the quantity x plus 5 is less than 3x plus 6. Distributing gets us 3x plus 15 is less than 3x plus 6. Notice I have a 3x on both sides. They would end up canceling out. Now I'm left with 15 is less than 6. Is that true or false? That's definitely false. 15 is not less than 6. So this is a contradiction. And what do our contradiction answers have? For an answer, no solution. What does the solution set look like? An empty number line with nothing on it. What if we made it plus 2 inside? So now we have 3x plus 6 less than 3x plus 6. If that was an equals to, then that would be an identity, and we would say all real numbers. But notice, when I eliminate my 3x's, I'm left with 6 is less than 6. That's still false. 6 is not less than 6. So that's another no solution, empty number line. For it to be true, it would need to have an equals to with that inequality, and then it would be all real numbers. So let's look at one of those. So here we have 3 times x plus 1 is less than 3x plus 6. So that leaves us with 3x plus 3 is less than 3x plus 6. Your 3x's cancel. Now I'm left with 3 is less than 6. That is true. So this is an identity, meaning every single number that we could possibly come up with would be a solution to this inequality. So for that, we shade the whole entire number line. And remember, we're in an interval notation for our inequality. So it's negative infinity to infinity for your answer for all real numbers. Please don't write the set of all real numbers because we use set notation for equations. This is an inequality, so your answer should be written in interval notation. Okay, so the math should not be much more trickier or more tricky or not tricky. It's the notation that's going to be new to you guys as opposed to the actual algebra. All right, the last thing we have to cover is 3-part inequalities. And this would be similar to the type of inequalities we're going to be using back when I started these notes. So we have 2 inequalities happening. If you were to cover up the whole right side, you would have, that simple inequality right there to solve. You would add 1, divide by negative 3. And then if you covered up the other side, you would do the same moves. Add 1, divide by negative 3. So now since I have 3 different areas, I'm going to do my operations to all 3 of those areas. So my first move is to add 1. I'm going to add 1 everywhere. So on the left of the inequality, in the middle, and on the right. So that gets me -1 is less than or equal to -3k less than or equal to 6. Now I'm going to divide everything by -3. What do I need to remember to do? I divide it by -3, so I got to flip the sign, which when you get to your final answer here, and you notice that you have a smaller number on the right-hand side as opposed to on the left-hand side, and you did not flip your signs, then that should be a red flag that you forgot to do something. Because if I were to rewrite this with my smallest number on the left and my largest number on the right, with k still in the middle, notice that right here, my inequality sign is open to the 1/3, so I need to keep it open to the 1/3 here. Notice here that my inequality sign is closed to the -2, so I need to keep it closed there. So that's what our answer would look like last year, possibly. Graphing it puts us at -2 on the left, 1/3 on the right, square bracket, shade in between. It's all values of k in between those 2 numbers. Interval notation, square bracket, -2, 1/3, square bracket. Okay. All right, try this one on your own and then we'll be done. Hopefully you got an answer of parentheses 3 to 13/3. If not, check your work. Hopefully you added 4 to both sides. So now you have 9 less than 3x less than 13. Dividing everything by 3 gets us 3 less than x less than 13/3. So on our graph, though you weren't asked to do it, just to see it, it'd be 2 parentheses, shading in the middle, which would get you to that interval notation. Okay, that concludes this video. If you need to go back and revisit anything, go back and revisit it. Thank you.